Hi students, welcome to today's class. Today I am going to teach you a very important chapter, that is straight lines. So this chapter is a very basic chapter in the geometry. This chapter helps you to solve so many problems from the geometry part. So this chapter and next chapter, pair of straight lines. From these two chapters in JEE Mains, you are getting at least one problem from this. Okay, now this chapter is also helps you to solve other problems in conic section, that is a hyperbola, parabola, ellipse. Okay, now so very in calculus also. So you are there where you are getting equations of tangents and equations of normals. There also this chapter is very important. Okay. So from the basic level onwards, I am going to teach you this chapter. Okay, now the first thing is, what is the definition of straight line? So actually speaking, there is no definition for straight line. Okay, now so it is an axiomatic term. Axiomatic term means what? A term which no need of any definition. For example, point does not require any definition. Like that, straight line is also does not have any definition, but line segment has definition. Line ray has a definition, angle has a definition, but a straight line has no definition. The only thing how we get the idea is, so take any edge of the any table. For example, if you see the edge of this blackboard, that gives the idea of the straight line. So this was explained in the Euclid's books, in the books Elements. So there he explained the terms which does not require any definition. So in that he mentioned that the straight line, point, they does not require any definition, like that plane, like that also. So that's why the straight line has no definition. In this video, I am going to explain what is the inclination of a line, what is slope of a line, what is equation of a line, what is the actual meaning of equation of a line. Generally, we will use the word equation of a line, equation of a line. What is the meaning of that equation of a line? These three topics I am going to explain you so very detailedly. So don't skip this video. So watch till the end. So you have a complete idea about these three topics. Okay, na? So without wasting our valuable time, so let us start our class. So coming to our first topic, it is inclination of a line. So the inclination of a line, or sometimes it is also called as steepness of a line. The other name of inclination is steepness. What is this inclination of a line? Okay. So let us take the two-dimensional coordinate system, x-axis, y-axis. Okay, now x-axis, y-axis. Let us take a two-dimensional coordinate system. Okay. Inclination of a line means it is the angle made by a line. For example, there is a line. It is a line. Okay, it is a line L. The line is making an angle with x-axis in the positive direction. What you call it as positive direction? Universally it was accepted that the angle measured in anti-clockwise direction. Anti-clockwise direction. So the angles measured in anti-clockwise direction. See here, this is called anti-clockwise direction. So if this is the direction, clockwise direction, you know what is clockwise? Universally all clocks run in a same direction. So this is a clockwise direction, this is called anti-clockwise direction. Universally it was accepted that the angle made by the line with the x-axis is called inclination of the line in anti-clockwise direction. This anti-clockwise direction is also known as positive direction. So this is called positive direction. So if take the protractor, you measure the angle. So let us the angle theta v is equal to 30 degrees. then this angle is called 30 degrees is called the inclination of the line L. Understand this. We should not measure the angle. For example, if you take this is called minus 150 degrees. This is called, if you measure the angle in clockwise direction, so that angle is treated as negative angle. So we have to take only, to mention the inclination of a line, we have to take only the positive angle only. We should not take negative angle. So always the inclination of the line is positive angle only. Okay now, right. Now I am going to take one topic. What is the topic? Sir, there is a line. There is a line. So for this is a line. So what is the inclination of this line, sir? What is the inclination of this line? Then what you have to do? Whatever may be the line, so you extend it. It intersects the x-axis somewhere. So this will be the inclination of the line. Otherwise, if you take any line is there, so this is a line. Okay, draw a line parallel to this line. Draw a line parallel to this line. Whatever may be the angle made that this parallel line with x-axis in anti-clockwise direction is called a inclination of the line. So generally students have an opinion that positive direction means they are saying that it should be make only with the positive x-axis. No need of that positive x-axis. Okay now. So for example, this is a line. If we extend this, it is making an angle theta with the x-axis. Okay now. That angle is treated as inclination of that angle. Okay. So the what is the so negative angles, we should not take the negative angle. So wherever may be the line, for example, if a line is here, you can extend this line. Otherwise, draw a line parallel to this. So these two lines are parallel. Whatever may be the angle made with the x-axis in anti-clockwise direction, which is called positive direction, the angle made the line with x-axis is called inclination. From this, you tell me one point, what is the inclination of x-axis? The inclination of x-axis is either 0 degrees or 180 degrees. Inclination of x-axis, that means what? The x-axis made the angle with x-axis how many degrees? 0 degrees. What is the inclination of the y-axis? Y-axis inclination is how much? Y-axis inclination is 90 degrees. So this is the angle made by the line with x-axis in opposite direction is 90 degrees. Okay now. From this we can say, any line, horizontal line, inclination is 0 degrees. Any vertical line, inclination is 90 degrees. So the horizontal line inclination is 0 degrees. The vertical line inclination is 90 degrees. Okay now, right. So here we have taken x-axis as a base. Okay now. You may ask one doubt, sir, why have to take only x-axis? Why can't we take y-axis? No. So such things, whoever developed the subject, they are taken x-axis as the base and they developed the subject. Okay now. So we have to follow the whatever may be the elders who wrote the books and who developed the subject, we simply follow. That's why they defined the inclination with respect to x-axis only. That's why we also simply follow their rules, follow their definitions. Okay, right. I hope that you understand this inclination of a line. So now what I am going to see is, what is, if there is a line, what is the minimum inclination and what is the maximum inclination that a line can make with x-axis. That means I am going to explain the range of the inclination. If theta is the inclination of a line, what is the minimum value and what is the maximum value. Okay na? So let us see that. Welcome back. Now what we are going to see in this topic is range of the inclination. Range of inclination of a line. that is theta. What is the range of that angle? So let us see this. So this is a x-axis and it is y-axis and it is origin. Okay now. Now what is the range of the line? Let us see that. Let us check that. Let us observe that this is a line, straight line. Let the line coincides with the x-axis. First the line is coincides with x-axis. First coincides that x-axis. Then what is the inclination? Theta is equal to 0 degrees. Minimum angle 0 degrees. Now if it goes on increasing. See here, if it comes here, what is the angle? 30, 40, 50, 90, again 110, 100, again. So this is equal to how much? Again if it coincides in this direction, so that means it raising like this from here starting point. So it coming here, again coming here, again coming here and coming here. See these angles. So these angles are increasing. So what is the angle? Theta is equal to 180 degrees. Okay now? Theta is equal to how much? 180 degrees. If it crosses the line, let us see what happens. For example, if it comes here again, if it comes here, coincides with x-axis, let us observe this point. This point you observe here. First it is 0, 10, 30, 30, 40, 50, 60, 90, 120, again it comes here. So when it crosses x-axis, again from there, the angle will be measured, again from this. When it crosses, again this angle will be measured from 0 degrees. So from this, what is the minimum value? 0 degrees. What will be the maximum value? 180 degrees. Okay now? So if theta is your inclination of a line, it lies between theta less than pi. Otherwise, you can write down theta less than or equal to pi, 0. Sorry, here 0 radians, that is pi radians. Otherwise, if you write down in the general form 0 degrees less than or equal to theta less than 180 degrees, or 0 degrees less than or equal to 180 degrees. Therefore, what is the minimum and the maximum inclination of a line? So the minimum is 0 degrees, the maximum is 180 degrees. Once it 180 it crosses, again it starts from 0 degrees onwards. Okay na? So that is the range of the inclination of a line. So nothing more than that. Only that is the concept regarding inclination of a line. Okay, right. So let us see a very important. From this inclination, what is the inference we can say? What is the inference we can say means it gives the stiffness of the line. Welcome back. So using this inclination, what is the inference we will get? Seeing the straight lines. See here. Here I have taken various lines making different angles with the x-axis. See here, the first line, second line, third line, fourth line, fifth line. By telling the angle, so for example, it is some 10 degrees, some it is some 30 degrees, some it is 60 degrees, it is 90 degrees, some it is 120 degrees. By telling this angle, we can tell the steepness of the line. How far it is steepness? How far it is steepness? If I tell that, so the line is making 10 degrees with x-axis means you can imagine the line, how far it is steep with x-axis. If I tell that the line is making 30 degrees with x-axis, if a line is making 60 degrees, if the inclination is 60 degrees, if I say inclination is 120 degrees, if I say inclination is 150 degrees, you can imagine the line. Okay. So if I say that, let us take two lines in the plane, that means different persons will give different lines. But if I mention the inclination of the line, let us consider two lines, one is 30 degrees and one is 150 degrees. Then you can imagine the line, how the lines will be there, what is the steepness, what is the steepness of this line. So this is a 30 degrees line, this is a 120 degrees line. You can imagine that will give, what will give? Steepness of the line will be Q. Okay, now we are going to see the slope of a line. If the same steepness is measured in if it is mentioned in terms of numerical values, for example, 5 by 3, 6, 12, 13, that will be very easy to understand the stiffness of this line. That is called slope. That means if the inclination of a line is measured in numerically, not without angles, numerically, that gives a new concept, that is slope of a line. Let us see what is the slope of a line. Okay. Welcome to this concept, that is a slope of a line. What is slope of a line? Already I told you, if the stiffness of a line is expressed in terms of some numerical values, that is 2 by 3, 5 by 3, root 2, root 3, that is measured in, expressed in terms of some numerical value, either positive or negative, then we say that that value is called slope of a line. Now already we know that, so if theta is the angle made by the line with x-axis in a positive direction, then the slope of the line is denoted by m, and it is given by m is equal to tan of that angle, tan of that angle. Okay, now, right. Now one question arises immediately. Sir, we have 6 trigonometric ratios. One is sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. Why we have to take the trigonometric ratio tan theta only? This question will be arises so many times in our classrooms. Why have to take tan theta? Why can't we take sin theta? Why can't we take cos theta? Okay, let us see that detailedly. Okay, now, so whatever may be the numerical value we will get. First I am telling here numerical value. For example, if it is a 45 degrees it is making, then what is the tan 45? 1. That value 1 is called the slope of that line. That is a numerically we are expressing. If it is making 30 degrees with x-axis, what is tan 30? 1 by root 3. 1 by root 3, that value gives the slope of that line. Okay, now our topic is why we have to take tan theta only. So to explain that, I am giving a diagrammatic explanation. So without skipping this video, let us see that. Welcome back. So now I am going to explain a very important topic. So that is slope of a line, that is equal to m is equal to tan theta, where theta is called inclination of that line. So why we have to take tan theta only? So that I am going to explain. Okay, first thing. Let us say that we went for a picnic in a very hill station, very big hill station, either Ooty or Kodaikanal or Nilgiris or Everest, Mount Everest. If you go to Mount Everest, there are different types of hills will be there, mountains will be there. So here different types of mountains will be there. Just by observing them, just by seeing them, we can have an idea. For example, if this type of hill is there, immediately you can say one thing, Arey Baba, what a stiffness. So for example, you are here. Can you climb this? Can you climb? Yes, we can climb, but it a little bit difficulty. So if you are here, so can you climb this? Yes, you can climb. How? It very easily. You can say one word you can say. What is that word? This is a very steepness, very high steepness, but it is very low steepness. You can climb the mountain. These mountains are also with a little bit difficulty. Comparatively this you can climb. So this has generally, in the general idea, anybody can say that this mountain or this hill has a more steepness and this hill has a low steepness. Okay. Try to understand this breadth is same. This breadth is same, length, breadth. Try to understand this. So this is breadth is same, but it is have a more stiffness, it is somewhat less, so. If you observe mathematically, if you think mathematically, it's a general form, anybody, an uneducated person, they can simply say that this has more stiffness, this has a low stiffness, like that you can easily climb. But if you think in a mathematical way, as a math students, as a JEE main students, if you think in a mathematically, there forms a right angle triangle here. There forms a right angle triangle here. If you observe here, if you take, there forms a right angle triangle. Whatever may be the stiffness, that gives the ratio of these two sides, whatever may be that, this side and this side. If you take this as a theta angle, so whatever may be the stiffness that is decided mathematically, the ratio of the opposite side and the adjacent side. The ratio of the opposite side and its adjacent side. If the opposite side is more, then it has a more stiffness. As the opposite side, it goes on decreasing comparatively adjacent side. Opposite side, adjacent side, it is comparatively, if it goes on decreasing, then your stiffness is also decreasing. In trigonometry, we come across what is the ratio which gives the opposite side and adjacent side. So it is not the matter. This is a hypotenuse is not that matter. This is the ratio, that is the opposite side, adjacent side. He has more ratio, more value. Here somewhat less, here somewhat less, here still less. Opposite side is still going on decreasing. Therefore, stiffness is also decreasing. Therefore, slope is also decreasing. So we use the word slope. It has a more slope. It has a very less slope. Understand? Very less slope. We use the word slope. Mathematically, so that gives, that slope concepts will give the ratio of opposite side to adjacent side. Opposite to adjacent side, opposite to adjacent side, otherwise adjacent to opposite, nothing wrong in it. So here opposite side and adjacent side. So in our 6 trigonometric ratios, which gives the opposite side adjacent side ratio? This is only tan theta or cot theta. Tan theta or cot theta. But mathematically, while defining, so we have taken tan theta. Why? Because that also have one reason. The reason is, for example, there is an hill. It is hill only, nothing is here. So nothing is here. So this is a nothing is here. Then what is the inclination here? 0 degrees. Therefore, any slope is there? No slope. For example, if it is a earth is there, any slope is there? Nothing is there. So what is the angle? 0. Therefore, if you put tan 0, then it will become 0. If you put cot 0, that is undefined. That's why, so to make you clarify, they have taken only tan theta instead of cot theta. Once again I am telling, so if it is no slope, that is 0 slope, that means inclination is 0. Inclination is 0. So it is a very easy to know, nothing climb, just to you can walk away. Here 0 degrees. That means tan 0, 0. No inclination, no slope, 0 slope. Understand here? So if you to take cot 0, it is undefined. So it is not undefined, it is defined. What is that? 0. Understand this? So I hope that, so you understand why you have taken tan theta instead of sin theta or instead of cos theta. Okay. So our basic primary trigonometric ratios are only 3. That is sin theta, cos theta, tan theta. Whatever may be the concepts defined, they will take only that sin theta, cos theta, tan theta only. Generally, we won't go for those secondary trigonometric ratios. Those are cosecant theta, secant theta, cot theta. We will take only tan theta. Okay. I hope that you understand better this concept, why you have taken tan theta. So once again I am telling, so whatever may be the slope or stiffness of a any thing, if you are defined mathematically, we will take this opposite side and adjacent side ratio. So whatever may be that, if you, for example, any electric pole is there, there is a strong wind came, there is an electric pole, strong wind came, So this is an earth. This is an earth. Basically this is an electric pole. A very big storm came, very big storm, a very big wind in the cyclone. So then it will become like this. Then become like this. One more electric pole is like this. One more. So from this, what can you say? Which have more steepness? So first one has more steepness, more slope. It has a more slope comparatively this. Actually, how can you decide? How can you decide has more slope, more inclination, more slope? Nothing. So it is basing on the calculation of this opposite side and adjacent side. This ratio tan theta is equal to opposite side y, adjacent side y by x. Basing on that ratio, you are deciding which has more steepness, not less steepness. Not the hypotenuse, only opposite side, adjacent side. Okay. So you understand this concept betterly. Okay. If it any concepts I will come across, definitely I will explain why we have taken m is equal to tan theta. Okay. So next we are going to see actually there are some more topics are there based on this slope. So let us see that. Dear students, let us see some important points regarding slope of a line. So what is the slope of a horizontal line is 0. Why? Because the horizontal line, so whatever may be that, so this is the x-axis, y-axis. The horizontal line means this is a line. What is the angle made by the horizontal line with x-axis? So draw a line parallel to this. So if it is a coincides, what is the angle? Theta is equal to 0 degrees. Therefore, what is tan 0? 0. Therefore, any horizontal line, whether it is x-axis or any line parallel to x-axis, its slope is 0. No slope, nothing. Okay. If the slope of the vertical line slope is 90 degrees. Why? So let us see the vertical line. This makes an angle 90 degrees with x-axis. What is a tan 90? Not defined. So if it is any straight vertical line is there, can you define the slope? No slope. So don't say no slope. We cannot define that slope. That's why not defined. If it is somewhat like this, we can define. If it is somewhat like this, we can define. If a line is vertically standing like this, can you define its slope? It is not at all defined. If it is like this, yes, we can define. If it is like this, we can define. Okay. If it is vertically like this, we cannot define its slope. Okay. If it is horizontal, we can say that its slope is 0. Okay. No slope, 0 slope. Okay. Right. Next we are going to see any two lines which are not vertical, okay, if they are parallel, no slopes, which are not vertical, their slopes are also equal, that is equal to m1 is equal to m2. Non-vertical hissing, very, very important. If you take a vertical lines, we cannot say. Why? Because first line slope is not defined, second slope lines is also not defined. Both those two quantities cannot be, we cannot say that whether they are equal or not equal. Two non-vertical lines are parallel if and only if their slopes are equal. What is the proof? Very easy. So extend these lines, extend line this. We know that two lines, this is theta, this is also theta. Two parallel lines make same angle with the corresponding, we call it as a corresponding angles, theta, theta, corresponding angles are equal. If these two are parallel lines and it is a transversal, these two are corresponding angles are equal. Therefore, here tan theta, both are same. M1 is equal to M2. Okay. If two non-vertical lines are perpendicular, that means what? So this is a one line, another line is this. If two non-vertical lines are perpendicular, so this is a non-vertical means it should not be parallel to y-axis. Both the lines should not be parallel to, either of the lines should not be parallel to y-axis. Then the product of their slopes is m1 and m2. The product of their slopes is equal to -1. You may ask one doubt, sir, you just now only told the slope of x-axis is 0 and the slope of y-axis is not defined. So these two are perpendicular. Therefore, 0 into not defined is minus 1. No. Now, I am only telling this case is applicable, valid when either of the line is non-vertical. Either of the line. Either first line or second line should be non-vertical. That means it should not be parallel to y-axis. Then only product of the slopes is equal to minus 1. Okay, now this case does not comes under this category except this case in everywhere the product of the slopes is minus 1. Okay, now so learn the subject conceptually. Okay, so without any hesitation, learn the subject conceptually. Okay, right. Now I am going to prove how when two lines are perpendicular, how the product of the slopes is equal to minus 1. I am going to see. Let us see that. Welcome back. So now I am going to explain you how to prove that if two lines are perpendicular, the product of their slopes is equal to minus 1. The condition is either of the line should not be, either any one of the lines should not be vertical. Okay. So for that, let us take a line x-axis, y-axis. Let us take a line, it is making an angle theta with the x-axis in the positive direction. Let us take another line which is perpendicular to this. Okay. So what is the angle made by the line with this? As we can measure, but in terms of explain theta, explain. So obviously this is equal to 90 degrees, this is equal to 90 degrees. If you take ABC is an triangle, theta is the exterior angle. We know that exterior angle is equal to sum of the interior opposite angles. So already it is theta, this is 90. What should be the angle here, so that if you add both the things you should get 90. So if anybody can say this is a 90 degrees minus theta. See here, add these two angles. Sorry. So this is equal to theta minus 90. Theta degrees minus 90. See here, whatever may be that, both add these two. So plus 90 minus 90 will get cancelled, theta is equal to theta. So here we have used the concept exterior angle is equal to sum of the interior opposite angles in a triangle, right. So the first line is making an angle theta, the second line is making an angle theta minus 90 degrees. Okay, the first line, second line. Let us find out their slope. So here for the slope is equal to m is equal to tan theta, call it as m1. So let the second line slope is equal to tan of theta minus 90 degrees. Okay, now tan of theta minus 90 degrees. That can be written as minus tan of 90 degrees minus theta. You know that theta minus 90, 90 minus theta, minus will come outside for tan, okay, trigonometry. So this is equal to cot theta. Tan of 90 minus theta is equal to cot theta. That is minus 1 by tan theta. Cot theta means 1 by tan theta. Okay, right. Here theta is not equal to 90 degrees. Try to understand here. If you may ask one doubt, sorry, if theta is 90 degrees, I already told that this should not be vertical line. It should not be vertical line. So here theta is equal to 90 degrees. That question does not arise. So this is m2. So what is the slope of the first line? Tan theta. What is the slope of the second line? Minus 1 by tan theta. So multiply this, m1 into m2 is equal to minus 1. Tan theta gets cancelled, therefore minus 1. So this is a proof of the concept. The product of the, if the two lines are perpendicular, the product of their slopes is equal to minus 1. Okay, now very nice concept. I hope that here the condition already I told, once again I mentioned here theta should not be 90 degrees, then only this case valid. Okay, I hope that you understand this concept. So now I am going to explain you what is actually meaning of equation of a line. What is actual meaning of equation of a line? We are saying that let us take equation of the line is x plus y plus 2 is equal to 0. 2x plus 3y minus 7 is equal to 0, like that we are saying. But what is the meaning of actual, how that x plus y plus will come? Okay, let us see that. Welcome back. So now I am going to explain what is the equation of a line. What is the equation of a line? Let us see that. So first let us take a two-dimensional system, x-axis, y-axis, origin. So these are the points 1, 2, 3, 4. So this is 1, 2, 3, 4, 5 and it is 6, so on. So this is equal to, this is a 1, 2, 3, 4, 5, 6, 7, like that. These are the points are there. You know the coordinates of that point. So here what is the coordinates of this point? So this is equal to 1 comma 0, this is 2 comma 0, this is 3 comma 0, this is 4 comma 0, this is 5 comma 0, this is 6 comma 0. What are the coordinates of this? 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4, so on. Now what is the common property that you are observing in by seeing all these coordinates? So if you observe, see here 1 comma 0, y coordinate is 0, y coordinate is 0, y coordinate is 0, y coordinate, that means y coordinate is 0. That means if you consider what is the common property that we are observing, we are observing y is equal to 0. If you take any point that is x comma y value becomes 0, that's why that y is equal to 0. That is a common property, that each and every point which lies on the x-axis, what is the common property that we have? Y is equal to 0. Understand? So if you take any point on x-axis, that point satisfies this equation, y is equal to 0. Take any point on x-axis, minus 7 comma 0. Substitute here, minus 7 comma 0, y value 0, 0 is equal to 0. So here two ways you have to tell. Every point on x-axis, y coordinate is 0, y is equal to 0, and every point y is equal to 0 satisfies every point on the x-axis. Similarly for y-axis, see here y-axis, what do you observe here? X coordinates are 0. What is the common property that we have? If you take a point x comma y on y-axis, what is the common property we have? X is equal to 0. That's why that x is equal to 0 indicates, that gives the total common characteristic of the points on the line. X is equal to 0. Okay, now I am going to see, I will draw a point which passes through 1 comma 1, 2 comma 2, 3 comma 3, 4 comma. So this is a line. So this is what you observe. This is 1 comma 1. This is 2 comma 2. So this is 3 comma 3. So this is 4 comma 4. In general, x comma x. What do you say? X comma y. X is equal to y. That x minus y is equal to equation of the line passing through origin from the points 1 comma 1, 2 comma. So what is the common property that we have? X is equal to y, like that. For example, if I say that x plus y is equal to some 3, that means what are the points? That means it passes through 1 comma 1 plus 3 means it passes through 0 comma 3. So whether you can say 0 comma 3 and 3 comma 0 and 3 comma 0, it passes through like that. So what are the other coordinates? This is a 1 comma 2 and a 2 comma 1 and a 0 comma 0. 0 comma 3, 3 comma 0, 1.5 comma 1.5, all the points comes on this line. So these points, all points which is satisfies the condition x plus y is equal to 3 belongs to this line. Okay. So the line equation means it is it gives the common characteristic phenomena that satisfies all the points on that line. Okay, so I hope that you enjoyed today's class with some more topics which are useful for your JEE mains examination. So in the tomorrow's class I will explain. Okay, so until then, all the best.